actually got a primer from Max on quantum mechanics before starting here. And he said that, you know, before you can become a quantum mechanic, you have to go to a trade school for a couple of years to learn how to use the really, really tiny wrenches that you need to use to get stuff done. So you're stuck with one of my 5th grade talks that I give to schools when I go out, but I'll try to stretch it out. And I thought I'd do rocks from space, since I'm known for hitting people with rocks. And you know, as usual, I didn't take the pictures. They come from real live missions, so you don't have the planets crooked and the polar caps cut off. So our solar system formed in a big cloud of, you know, junk, basically, and the sun turned on, and there was some leftover stuff after the planets formed in this nebula. And every once in a while, there's some of that junk that kind of deviates and heads our way. We've seen enough of that. Okay. And so when you see these things, usually they're about 70 miles up, and they hit the atmosphere and they ram heat the air in front of them, and it starts to fluoresce and you get a nice fireball. And if you hear the sonic boom, you know it's close. So that's when you want to start looking for meteorites, which are the things that survive and hit the ground. So I brought several meteorites tonight to pass around. There's like 50 to 100 tons a day of this stuff that hits the Earth. Most of it is really small, and you can have something give a pretty spectacular show that's only like the size of a grain of rice. Most of the big meteor showers you go out when they say it's 100, you know, zenithal hour rate, 100 per hour. Most of those are just little grain of sand or grain of rice type things, but they're traveling so fast that they heat up the atmosphere in front of them, and it glows, and it transfers some of that heat back to them. And if they're like iron, nickel iron ones, the surface melts and ablates away and takes away the heat. So it's not like you see in Hollywood when they hit the ground that they're starting forest fires and they're intensely hot. They've been cold soaking for billions of years, and they're often covered with frost when they're initially found, if they're sitting on the ground like that. But a lot of them just detonate and turn into little fine bits of flour that come raining down and cover up your coffee table, and are a good excuse not to clean. And so the dinosaurs didn't have a program to keep track of junk in space, so that wasn't very good news for them. This is, of course, an artist rendering of Chicxulub. And they just found, it's just been in the news this last week, they just found a site in Montana or North Dakota that they think dates back to like hours after that impact. And there's lots and lots of dead fish, because the center of the U.S. was a big inland sea at that time. And a lot of them in their gills had little bits, little glassy spherules and nasty stuff made out of essentially volcanic glass. And I have some of that to actually hand around. So those are called tektites. Oops, that's not it. And they're basically molten sand that's been blasted up by one of these impacts, and as it flies through the air, depending on how it spins, it congeals into various forms. They're often called splash-form tektites. These are from Thailand. There's a huge deposit there from something like 700 million years ago. So there's probably a big impact in the South Pacific somewhere. And this is a Philippine tektite. So I'm just going to pass this stuff around. You know, don't drop the heavy ones on your toes. You can look like a duck. But
question. On the tektite, how do they distinguish between that and just an ordinary volcanic bomb or a glass bomb from a volcano?
I don't know, but there's probably shocked quartz or something like that in there, would be my guess, that's characteristic of a meteorite impact. Yeah. You know, it's got shocked.
Once in a while you read a really small column in the paper and it'll say some woman was sitting watching her TV in Dalhart, Texas, and some little meteorite came through and killed her in the house.
No, there's no documented case of anything like that.
That's baloney?
Yeah, that's baloney. Now there is a lady in Alabama in 1947 that was hit by one, and it was about, I don't know, 6 pounds of rock that came through the roof of her house, bounced off the floor first, which saved her, and hit her in the thigh. And she had a huge bruise, and about 2 years of fighting with the landlord over who owned the meteorite after that. and the decision is that the owner of the property it ends up on owns the meteorite.
But very rare, right?
It's very rare. Now, there have been people's cars that have been hit, people's houses have been hit. Like in Chicago, there was a fall a couple of years ago. several people's roofs were hit, and there was a chunk that hit a fire hydrant and got some yellow paint on it. So the ones that hit something are called hammers, and they become collector's items, especially if they have yellow paint on them. And also the fire hydrant became a even if you don't own a dog. Peekskill, New York. I'm actually going to show that one. Yeah.
The key to this is speed. Apparently now these small ones, these little
They decelerate rapidly.
Okay, yeah, which burn up. Is there a minimum size to make it survive and hit the earth? What's the minimum size of the?
You know, you're probably talking softball to beach ball size, somewhere in there as a minimum size. It all depends on the velocity they come in with.
Okay, well, here's my stupid question for what it's worth. I'm thinking recently, something really big falling out of the sky is really awesome, and yet these damn Boeing 737 Maxes are bigger than that, and they've been falling out of the sky.
Yeah. In fact, that 737 Max made a crater 32 feet deep.
Oh, is that right?
Yeah.
So there might be something to it. I thought they don't ever devastate and wipe out their dinosaurs.
Yeah, well.
That one was, what, several kilometers?
This one was 6 miles across, and so it basically did not even see the atmosphere.
I see.
And hit with cosmic velocity, it just vaporized. And unfortunately, it's a shallow sea with a lot of limestone deposits, and that just made acid rain everywhere, and hot particles of rock falling down, setting on fires all around the world.
How big do you think the one on Russia several years ago?
I'll talk about that one. Yeah. Okay.
Yeah, that's the one that fell on the Yucatan Peninsula.
This is the Yucatan Peninsula. Chicxulub won about 66 million years ago. 65, 66. Yeah. This is a picture from the dinosaur space station.
Did we know enough to would we be able to dig it and find that asteroid?
Okay, so it vaporized. It
vaporized.
And the way they've gone down there and taken core samples, and it was a nickel iron. We know that because there was a layer. What first got them onto this was the Alvarez brothers, or father and son, were physicists and I guess geologists, and they were looking all around the world.
Is this round one?
Yeah, that's a tektite too. And so they were looking all around the world, and about at the KT boundary, which is this Cretaceous Tertiary boundary, they found a layer of soot and iridium. And they said, ooh boy, we think iridium isn't common on the Earth, it's common in meteorites, and it looks like there was some kind of devastating event with fires all around the world that about the time the dinosaurs went extinct. Wow, this is cool. We figured that there's probably a crater about 200 miles across somewhere that dates to 67 million years ago, but we don't know where that is. And some guy went and listened to their talk. Well, it turns out he was a petroleum geologist, and he went to listen to a talk that was given by Pemex in Mexico. And Pemex said, we were prospecting down in the Yucatan region, and we were doing our little soundings where we set off dynamite and do a CAT scan of the interior of the ground. And we see these concentric circular fractures, coming ashore in the Yucatan here, centered slightly offshore. And it looks like there was a meteorite that hit here about 67 million years ago, and it left a crater, 200 kilometers across, not 200 miles across, right? And this guy went to both talks, and he thought, gee, that sounds familiar, so he went to the Alvarez guys. He said, you guys should talk to Pemex, and they got together, and that's where they figured out that this stuff was going on. Okay, so, occasionally they hit, and they're fairly good size. This is the meteor crater in Arizona. And that Behringer crater, back in the late 1800s, Behringer was out here with a bunch of guys surveying the land, and he knew there were a lot of nickel iron meteorites that were found around here. Canyon Diablo is the name of them. There's one in the space lab that you can go touch. And that's the name of this canyon here because it has so many little curves and jots in it. If you get stuck in that, you're like lost, right? So they call it Canyon Diablo. And all of his buddies, all of the other geologists at the time, thought this was a volcanic feature. And so he thought, no, I think with all these meteorites around here, this is where a meteorite hit. And he figured, oh man, I bet there's a big blob of nickel iron at the bottom of this thing. So he bought this land and basically went bankrupt digging for the meteorite. And he found a couple of chunks that were like automobile sized. But that was it. So he went bankrupt, but his family still owns the land, and they're now running a museum, and so it all worked out. But this is another case where it hit with cosmic velocity and it just vaporized. There's a trail of microscopic nickel iron particles trailing away from this that goes all the way to Kansas. So there's a big plume of bad stuff.
If you'd been anywhere near that, you would have been instantly killed, right?
Yeah, probably not good to be anywhere fairly close to that. And it was 50,000 years ago. I don't think the area was populated back then. I mean, I think anthropologists are still arguing over when the Native Americans got here, but it was probably pretty empty back then. Not a nice place to live anyway back then. But you know, people do. So here's the Peekskill meteorite. This is the one that there's tons of videos of this if you go out on the web. In like 1998, and it was high school football season. So you get all these videos of people that are high school football games, and you see the cameras pointing down at the field, and all of a sudden it shakes, and you see it go up in the sky, and there's this meteor coming through and dropping off fragments and stuff and making sonic booms. And this lady was sitting in her house, and she heard a big thump, and she went out, and there was a hole in her carport, and there was a big ding in her Chevy Nova, and there was this rock sitting there, and her car tripled in value immediately. And the rock did too. But it just was a stony. You can see it's got the fusion crust, but some of it got broken off where it hit here. And so that's a characteristic of meteorites that you find on the ground, the stony ones. Otherwise, it's sometimes hard to tell from a regular rock, of course. And I'll show that. I'll show you some.
Where did that car and meteorite end up at?
I really don't know, you know. I know she sold the car for something like $48,000. I don't know what happened to the meteorite. I mean, it probably went to, in some collection.
It'd be a great museum piece to have the two together.
Yeah, oh yeah.
Yes.
Oh, what do we do? Oh, okay, still got my title. So there's three main, yeah. Mm-hmm.
How come there's so much iridium in so many asteroids?
Apparently, it's a common byproduct of supernova explosions and neutron star collisions. It gets produced, and so it ends up, the nickel iron itself comes from that, and this is mixed in with it. It's not like it's a huge proportion of it, but it's higher proportion than you find in the crust of the Earth. So when they found that increased iridium layer, they knew something was going on. And it's heavy, so stuff that landed with iridium in it early in the Earth's history would be molten and sunk down in now, would be in the crust as much. Okay, so there's three main types. Irons, they're the most commonly found because they're tough and they survive well. But the most that fall are actually stony ones they're pretty much like rocks on the Earth, although they have some features that you can use to distinguish them. And then these are real general catalogs. There's a bunch of other little subcategories. But then there's also stony irons, where you mix the two. And I've got my definitive nickel iron meteorite here. And anybody who's been in a star party has been hit with this. But, so if you're allergic to nickel, wash your hands. It's a nickel iron meteorite. It's called Campo del Cielo. It was found in Argentina in 1576. And it came from out between Mars and Jupiter from the asteroid belt. It's 92% iron and 7% nickel, so it smells like Las Vegas. And it's the oldest hunk of junk you'll hold anytime soon. By looking at isotope ratios in it,
we can tell that it crystallized between 4.5 and 4.6 billion years ago, so it's older than dirt.
I can never get the school kids to do that.
You know what you should have the teacher have them memorize.
Or cue cards, yeah.
No, have them memorize.
Yeah.
When you hear Chuck say this word, everybody's
Start
memory
up.
kicks in.
So this is what we think happens. The irons come from a body that differentiated. So you got something that had to be big enough, that had enough internal heat that it melted and all the heavy stuff went to the bottom. So you got an iron core, you've got a stony crust of some kind, and then you've got the stony irons come from the interface where these kind of mix together. And so those are much rarer to find out there, and get made into jewelry and all kinds of things. And you'll see why. So I have a let's see. Okay, so iron meteorites. So there's the Campo del Cielo. There's a piece of Gibeon. This was found in Africa in 1836. And this particular piece has been sliced and etched with nitric acid to show there's a very characteristic thing called a Wittgenstein pattern, which is a crystal pattern of these nickel-iron alloys that form. And of course, I've been handing this box around so much that it's scratched up more than the meteorite is, so it's kind of hard to see. But
Say that Wittgenstein.
Wittgenstein.
Wittgen.
Yeah.
Wittgenstein.
Wittgenstein. So anyway, here's the Gibeon. If you kind of tilt it to the light, you can get a hint of the crystal pattern. But that is diagnostic of a meteorite as opposed to a meteorong because it forms in low gravity. So it's kind of, it gives you an idea that this thing, oh, and the stuff in the containers, please don't open up the containers. It's to protect them from our atmosphere, from water vapor in the atmosphere.
So check, it's low gravity or long time period?
Both,
Yeah.
both. Cooling over a long time period in low G. So it's kind of hard to fake. Although we're probably trying that on the ISS, who knows. And then this one here is called Nantan. This one's got a good story. It's highly polished, but on there's a nodule on the pointy end, there's a little nodule of graphite that's still in it. On the Campo del Cielo, you'll notice there's some holes or thumbprints, they're called regmaglyphs. That's where there were blobs of stuff like graphite that burned out on the way in. This one still has a graphite nodule in it. And this is a little piece, in most cases these are little pieces of much larger falls. And the Nantan has an interesting story. It was actually discovered in 1958, but it fell in 1516. And the story is that Mao was trying to get industry out into the hinterlands, and so he was going they were sending out these smelters to these little villages and saying, okay, we want you to make 500 pounds of steel this year. And a bunch of the villages were kind of like, we got to get iron ore. How are we going to do that? And so they ended up melting their pots and pans and stuff like that. But there was this one village in Nantan province, and I think it was Nantan village. And they were going, hey, we're lucky. We're always running into chunks of iron when we're plowing our ground, And so they took a bunch of these rocks that they found and they threw them into the smelter and they wouldn't melt. And so they complained to the central government. They said, hey, what's the matter with you guys? You sent us a faulty smelter because we got iron ore. We're throwing it in there and nothing happens. So the government sent a guy out and he says, hey, smelter's working fine. So they sent out another guy, a geologist, and he looked at it and he said, it's a meteorite. And it's got nickel in it, so it's more refractory. And that, you can't melt it. And that's actually what saved the Campo del Cielo pieces. We say that was found in 1576 because the conquistadors wrote about it. They found 35 tons on the surface, and they thought they were going to be making cannons out of it. So they wrote about it and got credit. But they couldn't melt it with their technology. It wasn't until like the 1860s that people could melt, could get those temperatures in smelters. So anyway, they looked back in their old annals that they had, the old, diaries of the county, and they found a night, in May of 1516 when there was a flaming dragon in the sky making noise all night long, and so they figured that's when the meteorite fell. And then these are sea codalines. This was a fall in 1947 in Siberia, or out in the offshore islands there, and it was seen to fall. And there's several tons of it, and one piece here tumbled kind of chaotically, and it's got lots of regmaglyphs, and then the other piece spun like a bullet, so it got formed. As it was ram-heating the air, that air was transmitting heat to it, and it melted, and you can see flow lines where it melted and actually dripped off the back side of this as it was flying. So, again, it's not too bright in here, but if you kind of tilt it around in the light, you can get some idea of the flow lines on it. So those are nickel irons. Those are the most commonly found just because they survive well in the Earth's conditions. It turns out that stonies actually are the much more common fall, but they often have lots of nickel iron in them still, especially if they're from undifferentiated bodies. And when the iron rusts, when it's exposed to water vapor, it expands and they crumble apart. So,
Are these pictures of yours?
Most of them are. Some of them are not. Like that one isn't.
Well, the one with graphite nodule, right?
Yes.
Is there a possibility that graphite was once a diamond?
Was once a diamond. I don't know. Can you do the reverse?
Yeah, well, diamonds form under high temperatures and pressure.
Yeah.
But if a pure diamond is unstable and it gradually, under low pressure, it gradually reverts back to graphite.
Oh, cool.
So,
Could be.
but
Yeah.
the way people's rings the diamonds do that is because they get pacified, the surface gets stabilized by hydrogen bonds.
Okay.
So they get polished in olive oil, and that makes them, so they don't do that here on Earth.
Ah, okay. Yeah, I don't know. Could be. Could be that was a diamond under, and now it's somewhat decreased in value. Okay, so what happens to make these irons come here? They had to come from the core of a differentiated body. Is you have collisions all the time out there, and this, of course, the fifth graders like explosions. So we have an explosion here. But those things get broken apart in collisions, and pieces fall downhill and end up falling on the earth. So, like for that Campo del Cielo, it was 85 tons that was eventually found. And so that had to come from, a good-sized body, maybe 100 miles across.
Chuck, I heard something about a lot of meteorites come from Vesta. Is that,
Yes.
Do you know what fraction or just a lot?
No,
I heard
it's
like almost 25 to 40%, or
well, it wasn't Vesta. It was another one called Hebe, I think, that they thought a whole lot of, especially nickel irons, came from. Now, the Stonies is a special kind. There's like Howardites and Eucrites and some other name. There's a whole category of those that are weird, and they think those came from Vesta.
Okay.
And that's some percentage of the Stonies. But yeah, pretty common.
What about the ones from Mars?
I'll get to that.
Okay.
So here's a little bit better picture of a polished Widmanstätten pattern, so you get an idea of what's kind of going on here with these cubic and tetrahedral crystals, which is all messed up and when I passed around. So now, you don't just find meteorites here. This is actually one was found on Mars by the Opportunity rover. They were going to, from orbit, one of the orbiters saw their heat shield and their parachute, and so it was within driving range. And so they said, okay, well, let's go take a look at the heat shield to see how well it performed, how much it bladed away, because if we can make a lighter heat shield, we can put on a better instrument, right? And save some weight. And so Opportunity went, and as they were heading to the heat shield, they bumped into this thing, and you can see where they kind of scraped it up with their little arm with the drill and the spectrometer. And it's nickel iron. So this was the first nickel iron meteorite found on another planet.
Wow.
And the way they characterized things that they discovered with those rovers was, they didn't give them like coordinates or something. They had a person on duty each day whose job was to name things, so you see these weird names sometimes for some of the geological features, but they also named individual little things that they found. And it'll be rivers of the world or Sumerian gods and goddesses. Or on this day, it was a guy who was fond of cartoons, so this thing got called SpongeBob SquarePants. But now they call it the Opportunity meteorite. I think it's on the order of like 2.5 feet
Wow.
across. Yeah. Wow. They're not going to lift it and bring it back. That's for sure.
So it's still up on Mars.
It's still up on Mars. So we also have stony meteorites. These come from the crust of a differentiated body, or they come from a body that never differentiated at all. And all the ones that I have as examples are undifferentiated. So these come from primitive bodies that never formed into a larger thing, and they're not brecciated. They're not chunks of rubble that have been re-amalgamated by multiple collisions on things. So you'll see a lot of them will have names, like these will all have names like Northwest Africa 869 and stuff like that. Because there was a guy in the U.S. in the 70s who realized that deserts are a great place to look for meteorites because it's dry and you don't get the rust that would cause them to fall apart. And it turns out now Antarctica is like the best place to find them. But anyway, he traveled to Northwest Africa where there are all these nomadic tribes who go out in the desert. He brought a couple of examples of meteorites and said, hey, you guys, while you're out there, if you see something that looks like this, bring it to me. I'll pay you 15 cents a pound. And he got thousands and thousands of meteorites. And they didn't have GPS, so they couldn't, normally they name them after a town or a geological feature near where they're found. And so these are all called Northwest Africa or Sahara with some long number potentially, Sahara 99676. So these are all undifferentiated. So they have, they're what are called chondrites. And they have little chondrules in them. And the chondrules are like little balls of stuff that's stuck together to eventually form the rock. And of course, we don't have a lot of light, so it's probably better in the back or if you have a flashlight. But if you look at them, you can see the little chondrules, except for in the case of this Northwest Africa 869, which just looks like a couple of little rocks. But you can see the fusion crust on those. But in these two that are sliced, the Sahara and the other Northwest Africa, you can also see that there's a large amount of nickel iron in there, especially if you tilt them to get the light, because the nickel iron looks shiny. So here's some stonies. And they're the most common to fall, but they're not common to find. Mhm.
About 10 years ago, there was an asteroid that hit in the Sahara Desert. They spotted it in space.
In Sudan, yeah.
Yeah. Is a piece of that available? Do you have a piece of that?
I don't have a piece of that.
Okay, so
That,
do you know what it was? Whether
it was a stony iron. It was a chondrite.
Okay.
I don't think it was a carbonaceous, another class I don't have in here is a carbonaceous chondrite. They're even more primitive. They have a lot of graphite and carbon and water and salt in them. Really interesting stuff, amino acids. I don't have any of those, so they're expensive. And this one from Sudan is pretty expensive too, because it's a kind of a in the news fall. But you can't get pieces of it.
What are the ones, or maybe you'll get to it, that have the sapphires or peridots?
Yes, yes.
Yeah.
Those are the stony irons.
Yeah.
So you can see these guys with the chondrites. So then there are, and these form, this is when little bodies accrete together. So these are the little things that eventually become the chondrules in there. And they stick together, but they never get big enough to have enough internal heat for the whole thing to melt. And they never get incorporated into a larger body. And they may get broken apart in collisions and stuff, but they tend to be, small bits. And they're not metamorphosed, I guess you'd say. They haven't been melted and differentiated and formed into new type crystals. So they're kind of the original building blocks of the solar system. And here's kind of a sliced example to show the chondrules. So it's just all these little bits of silicates. A lot of them have been heated, and they think what happens is, depending on where they formed in the solar nebula, they got more or less heat, but a lot of them got heated to high temperatures because they came in close to the sun, and then they got thrown back out by some process and ended up out there accreting into these babies. So they didn't all form out there in the cold. Now there are some stonies that people find that are weird, and this is one of them. And this one's called a Shurgatite because the first type class of this kind fell in Shurgati, India in like 1880, something like that. And they were good enough with physics and nuclear chemistry and stuff back then to figure out that some of these things were really, really old. And most meteorites were like 4 billion years old. But these were 2 billion years old. It's like, whoa, little babies. And they were basaltic lava. So they had to come from someplace with volcanoes. So they could come from Mercury, they could come from Venus, they could come from the Earth, they could come from the Moon, they could come from Mars, And people used to think that all meteorites were just stuff that were barfed out by volcanoes on the other side of the Earth that came falling down. It wasn't until the 1840s that they realized that these things were really coming from space. So these were a big mystery to have these young things, but they could tell they came from somebody that had volcanoes. And it wasn't until 1976 with the Viking landers on Mars that these Shurgatites, among the Shurgatites and Nakhlites, and there's another name that I forget, but they come from Mars. They have bubbles trapped in them that match the isotopic composition of the atmosphere of Mars, measured by the Viking landers. So here's a little piece of Mars. This came from a volleyball-sized chunk that was found in the Omani Desert in like 1999. So it's called Sialuhaimir. I'm just amazed that Joe Blow can go and have a piece of Mars. Back in 2003, there was a sale on Mars rocks, and that's when I got it. So.
Are the Vikings at all operating still, or are they?
The Vikings are long dead. Yeah.
So you Joe Blow the second then?
Yes. They're the third, somewhere along the way. I mean, it's a little piece. It's just a little cutout piece, but it's still, if you take the amount that has fallen to the Earth, it's minuscule. Now they're finding a lot more in Antarctica, so there'll be a lot more of this stuff probably coming out in the collections. But Antarctica now turns out just a perfect place to look for meteorites. It's white, it's flat, it's uniform, it's dry actually, and the ice moves and deposits big drifts of these meteorites. And there was that ALH 8401, which is a Martian meteorite, and it was the one that had the little potential, microfossils in it, quote, quote. That one spent 10 years in a drawer before they looked at it, because they found it in Antarctica, and they found so many they just didn't have time to look at it. So we're getting lots and lots of meteorites now from Antarctica.
When science says, or they say, that something is only so many millions of years old, it was born, they say this about Earth rocks too.
Yeah.
Goes back so many million years. material in them was here before, what's defined as the beginning, the birth of a rock?
When it crystallized in the solid form, when it was not molten, you know, when it went to its current form. So what you can do is you can look at the decay products of uranium going on down to lead, and from their relative proportions in an object, you could tell when it last, you know, became solid, basically.
From what you're describing, I drive a school bus down Modoc Road to, I think it's on 45, it's a U-shaped neighborhood.
Uh-huh.
And when it was raining so much, it was like a little mini lake right there along Modoc. And by now, it's just kind of getting more solid.
Yeah.
It's
The
like,
sediments
it's
in there,
like
yeah.
all this lake, and then it's like sediment, like you're saying. And then
Yeah,
all of a
like
sudden
cement.
it's solid.
Yeah.
And the little preschooler can't understand the different stages, so we've been trying to discuss it. She's the only
Okay,
one
see?
of us, so.
Geology from a bus trip. Uh-huh.
Did they ever resolve what the fossil was or whatever it was on that
No.
meteorite from Mars?
So that ALH 8401 had all these tiny little granules in it of magnetite, and their crystalline structure. They look like little beans, elongated beans, and that's exactly the kind of structure that's made by bacteria on the Earth that live in rocks. And they form these magnetite crystals in their cells. I was going to say bodies, but you know, in their cells. And they use that to somehow sense the magnetic field of the Earth to do whatever bacteria is worried about, right? But these look just the same as those. And they also, within that same meteorite, and this was well in, you know, they had to slice it and get well in there, so it wasn't contamination. It came from Mars. They also found these polycyclic aromatic hydrocarbons, which are like the gunk on your barbecue. And they come when living things decay. And both of those can be produced by geological processes. The trouble is, the temperatures at which they form are incompatible to have the two of them together. So it was a really hugely interesting result. It wasn't proof that there's, you know, bacteria crawling around on Mars, but it was really interesting. And they metabolize sulfur and whatever else they find down there, and they burp off methane. And we're finding episodic blobs of methane in the atmosphere of Mars, which gets destroyed by the ultraviolet light from the sun. So something is pooping that stuff out. And we're seeing it on Mars when the seasons change, when it warms up. And it also seems to be concentrated in areas where we're finding water under the soil on Mars. So it's a bunch of really interesting things pointing to the chance. You know, you're not going to find deer and bunny rabbits hopping around because it's cold and it doesn't have a magnetic field to protect Mars from radiation from the sun. But you could have stuff like this living in the ground on Mars. So it's real interesting. Now, the sizes of these things that they found, the sizes of the putative little bodies and the little crystals, were similar in structure but much smaller than the ones on the Earth. And so the question was, could they have enough genetic, you know, mechanism in there to actually be living things or not? And that's still a hugely open question. So it's just really cool results, but not proof of anything.
I'm making an assumption that rocks on Earth and Mars were caused by some sort of collision of bodies with Mars.
Yes.
I don't know what else would cause that. But my question was, you were referring to this one as having been 2 billion, rather a youngster compared to everybody else. When do you recall was the late bombardment?
Late heavy bombardment was like 3.8 billion in that neighborhood years ago. And what's really disgusting about the Scialluhai, about the Martian ones, is from the Lunar Reconnaissance Orbiter, they think they've identified 2 craters that these things might have come from. Low angle impacts are better at splashing stuff out without overheating it into escape velocity from Mars. And they found 2 of these elongated craters in areas that have basaltic lava that match this spectrally that they can see from the spacecraft.
Well, so how old is the Valles Marineris? Because they don't know how that formed either.
Yeah.
Could have been in a comet
or just a crack as the crust cooled.
Could have been.
Yeah, but it's been modified by water. It really looks like, you know. Yeah, so, I mean, yeah. And the Scialluhai spent something like 16 million years in space before it landed here. And that they can tell by looking at cosmic ray defects in the crystal structure. And so they can look at the rate at which those happen and estimate how long it's spent getting here. So people are smart. Now the rarest kind of stony meteorite, and here's an example here, is stuff from the moon, because it turns out the moon is so similar to the Earth as far as the rocks, that it's very hard to tell you've got something from the moon, unless of course you brought it back yourself. But nobody's allowed to own anything that was brought back from the moon, at least in the US by the Apollo astronauts. You read occasionally about people getting into big trouble for having, pilfered pieces of that. So here's a good example of some false advertising, but these are the most expensive in general meteorites, just because they're so rare. But here is one that is a piece of Mars that just fell to Earth as a meteorite. And late heavy bombardment was probably blasting the moon with all kinds of stuff. So there's probably lots and lots of lunar meteorites that are sitting around. It's just identifying them that's the problem. So this is a little piece of another Northwest Africa type meteorite, tiny, tiny little fragment that of a piece that landed in North Africa and was identified as actually coming from the moon. So a piece of the moon too.
If you wandered on the desert surface with a metal detector, what depths would these be at?
Often they're right on the surface.
Not even below the...
Right, because they really most of them hit with just the velocity of an unlucky parachutist. And they slow down and then they just fall. And so, and if they're small and flaky, they're even slower. So, yeah. And occasionally they're very, like the Brenham, Kansas, they have a lot of pallasites, which are these stony irons, and they're a couple of feet under. So that's a rare one, but just only a tiny piece because they're rare. So then there are the stony irons, and these are rare, and these are very popular for making jewelry and stuff because they formed at the boundary between the core and the crust, and so you've got the nickel iron matrix, and you've got all these crystals, olivine and peridot embedded in them. And that's a really horrible picture, but I have a much nicer one here. This one is called Fukang, was found in China. This was like, big, this piece. So this is just a tiny little slice that's been put in plexiglass to protect it, but hold it up to the light, you can see the peridot crystals and a nice nickel iron matrix that it's in. So those often get made into watch faces or fancy jewelry. And it's just a chance for me to say, hey, have you got my Fukang meteorite? Okay, so I won't say it. Okay.
The fifth graders like that one?
The fifth graders usually don't hear that one. So most of this stuff, comes from the main asteroid belt. We had Joe Chatelain come and talk to us about rocks out there in space. So you have the main asteroid belt, and of course this has been really condensed down, so they look really dense. But even though there's billions of them out there, the average distance between anything of any reasonable size is like 1 million miles. So there's a lot of space. And then there's the Trojan asteroids that are in the Lagrange points around that are stable with the orbit of Jupiter. So that's where most of this stuff comes from. Collisions with those that send them in, and we have near-Earth asteroids too. They're like bigger chunks that haven't hit us yet that come through the inner solar system. And those are the ones we have to pay some attention to. And so there's missions out there to explore these asteroids. There's the Psyche mission, I think it's called, that's going to go out and try to look at these Trojan asteroids in the future. And right now we have OSIRIS-REx and Hayabusa that are active. And so you also see out there, you see families of meteorites. And so you get a meteorite that maybe grew big and had nickel iron in its core, and then it gets broken apart in a collision, right? Because that's how we end up with a small piece landing here. But those pieces tend to have the same orbital characteristics still. And so you see these clouds of these guys that share orbital characteristics. So you have different families of these different meteorites. And so you see pieces of Vesta from that big collision, and they fall to the Earth and stuff like that. So asteroids also have moons. So this is Ida, and it's moon dactyl. This is like 30 miles across, and this is like 2 kilometers across or something like that. So this little moon going around. We find quite a few of them are binary or contact binary objects with dog bone type shapes. There was this Itokawa that was actually visited by a Japanese Hayabusa spacecraft, and they tried to bring back a sample. They didn't have much luck with that. A lot of them are rubble clouds, like the for the fifth graders, Itokawa is dog poop that's been rolled in gravel. Right? So, and so that was Hayabusa 1, and now Hayabusa 2 currently is in orbit around Ryugu, and they're going to try to bring samples back. And they've already come down and basically touched the surface. As they got close to the surface, they fired a projectile made out of tantalum to make a splash of debris, and they have a horn-shaped collector, and they collected some of the debris from it, and then they backed away again. And they use pure tantalum because you don't find it in meteorites in general, and so they can tell what's fragments of their bullet and what's stuff from the asteroid. And they just detonated a bomb basically on Ryugu, and it's an explosively formed projectile. They had a big sheet of copper, and then they had this lens of explosive, and they dropped it off, and they went around. You know, they didn't want to be hanging around with the spacecraft when this went off, but this thing descended, and then at some height above Ryugu, it detonated and formed this molten slug of copper, pure copper, that went down and excavated like a 30-foot crater. And so they figured their first sample comes from the surface, from the regolith, that's been exposed to sunlight. But they want to see the stuff inside that hasn't been exposed to sunlight and cosmic rays and stuff. And so they're blowing this crater out, and they're going to wait a little while for the debris to kind of settle back down. And then they're going to go try to collect another sample from that and return it to the Earth. So I think they're going to come back first before one of these other missions is going. And this thing is, 1 kilometer in size, okay? So half a mile across, and it's diamond-shaped. And there's OSIRIS-REx, that's a NASA mission that just went to Bennu, which is a near-Earth asteroid that has a good chance of hitting in the 22nd century sometime. And it's also diamond-shaped like this. So what it is, it's a rubble pile, but it's rotating rapidly, and so these pieces migrate to the equator, and they've seen this one even spewing stuff off at the equator. It's rotating so fast that when something causes a little avalanche here, a piece of rock can get enough velocity to go flying up, and eventually they fall back down on it. They're not getting escape velocity, but it's just one more thing they have to worry about when they're going to come down and land and try to do things with the surface. And so that's in the news today, that they just did that explosively formed projectile. So there'll be more news from Ryugu and Hayabusa 2. So we have the OSIRIS-REx mission, and that's near this asteroid called Bennu, which is about half the size of Ryugu. But look, it's got that same diamond shape, it's got the same rapid rotation, and it's much bigger particle sizes than they expect. Oh, also on Ryugu, they just measured its density too. And they figure it's 50% empty space on the inside. So it's a real pile of rocks with not much dust filling it in. But this thing's much bigger cobbles than they expected. They expected fine-grained stuff to be in there, and they're finding that it's chunks of rock that are a couple of inches across. And so they're having trouble finding a flat enough space to land and do their collection that they wanted to do. They're going to come down, and they have this long arm that they stick out, and it has a plumber's helper on the end, basically. And it's going to come down, and it has sticky stuff around on that. And it's going to come down and just whoop, on the surface and pick up some sticky stuff. But right as it connects with the surface, they're hoping, of course, it'll seal, and then they're going to puff out nitrogen gas to poof up stuff from the surface and collect it. And they have enough nitrogen gas to do 3 of these collections. And they figure they're going to take up to 5 pounds of samples that they might be able to bring back.
Are they going to do that on the fly, or are they going to land?
On the fly, they're going to kind of bounce.
They're going to have to match the angular momentum.
Yeah, the rotation and everything. Yeah, they're going to have to be real careful. And they're having real trouble finding a big enough space to do that on that's flat enough and safe enough. Because some of these boulders are pretty big. Actually, I think this is actually an animated GIF here of the rotation. So you can see this is like a pretty good sized boulder here. Yeah, that's a good chunk there. So
They're taking a real slow boat home though, right?
yes, Hayabusa's coming back pretty quickly. Much smaller sample size. This one's not coming back till 2023, I think. With samples, they're going to land them in Utah.
What's the time scale?
The rotation is like 7 hours, I think. Oh, it's pretty fast.
Yeah.
Russell, did you have?
Oh, so that's their day.
That's their day, yeah.
And it's freezing on the other side, huh?
Yep, yep. You get out of the sun, it's getting pretty cold, but of course, you don't have a whole lot of time to cool off, so some of the warmth might remain. And its year is not as long as our year.
Looks like there's a Mario there.
Yeah.
Did you say this was gonna hit us at some point?
Yeah. This is like the number 2 rated as far as chances of hitting us, and it's like 1 in 2,700 in the year 23 something or other.
That's amazing diamond.
Yeah. And it's a rubble pile, so you know, it's sort of good to know that it's a rubble pile, because then you don't try to go detonate a nuclear weapon next to it and hope that works, because you turn it into a shotgun blast instead. So you're gonna have to figure out how to go up and push these things gently, or toss a big net around them or something like that.
How far is the spacecraft from the asteroid?
It's in an orbit that's only like 2 miles up or something like that. It's really close. This thing's only 500 meters across.
And the orbital period of the spacecraft is?
I think they're trying to match it with okay, and these are coming out of dusty corners here, so it might not be the right numbers, but it's something like 7 hours or 7.5 hours.
It's 4.3 hours.
4.3? Okay.
Yeah.
Okay, maybe I'm thinking of Ryugu. So they're going to try to match, of course, match up really carefully before they go down and touch with this long arm that they have.
You said the word, I think, tantalum?
Yeah.
What is that? I've never heard of it.
It's an element. It's a metallic element. Yeah.
What number is it, do you know?
No. I don't know.
Is it an explosive element?
No.
Come on,
No, it's a
Chuck,
metal.
you know,
Yeah.
Never heard of tantalum.
We can look it up.
It's used in capacitors, in electronics.
Really?
Yeah.
Okay.
It's
Some wire, specialty wire.
mhm. Okay. So we're talking mostly, stuff from the asteroid belt, which is way down in close.
Okay, thank you.
So in addition to rocks, we have icy stuff. So there's the Kuiper belt, which is a disk much like the asteroid belt, but far out here. There's Pluto's orbit, I guess. And then you've got this Oort cloud that goes up, 100,000 AU. I mean, that is big. So up to 2 light years in radius. Huge cloud of icy stuff, and that stuff we're also looking at. Of course, when you see it here, we see it in the form of comets, and as the ice, the volatiles are coming off, you get these tails that show off of them. And we actually went to measure, because one idea is that water might have come from these. So back a couple of years ago, I don't remember when, but I know a bunch of us were up at the gun club watching this happen. This is Comet Temple. They actually sent an impactor and a dual spacecraft, and it dropped off an impactor, which is like washing machine size, made out of copper again, so they could spectrally subtract it out. And they just parked this washing machine size thing in the path of the comet, and then they withdrew and they watched as it hit, and then they took spectra of the debris. So here's the view from the washing machine, from the impactor, as the comet came along, and they splatted into it. Not very good resolution, it's just like a webcam.
The mission called Deep Impact.
Deep Impact, yeah. And a bunch of us were up at the gun club, and we watched, and 15 minutes of light travel time after the event, we actually saw a slight change in the brightness of the comet, so that was cool. And here's the view from the mothership. Boom. So washing machine sized explosion, oops, okay, I'm not good at that. Anyway, boom. And so they measured the spectra. And what they wanted to know is, did water on the Earth come from comets? And in this case, it did not match spectrally, I believe, with the water we found on the Earth, but with some comets it has. And so, but it also matches some we see in meteorites. And so they think that basically we got water from both. And this is the rubber ducky. This is Churyumov-Gerasimenko, that the European Space Agency just had the Rosetta mission go. And they orbited this. They had a little lander that, of course, landed in a little crack, and they didn't hear that much from it. But they were, again, looking at the water and stuff coming off of this. They found all kinds of organic molecules. You can see it's spewing stuff off. And I think this is another rotating view of a day on Churyumov-Gerasimenko, which I think was 6 hours. And so they found all kinds of organic compounds and ammonia and smelly stuff on there. And they also looked at the isotopes of hydrogen and oxygen in the water, and it doesn't match the Earth's water. either, so we didn't get it from the rubber ducky. And this is a view from the surface taken by the little lander, showing you all the stuff being spewed off. Now you'll see some stuff that moves regularly like this, and those are the stars in the background as this thing rotates. But you'll also see just this snowstorm of stuff, you know, blasting off this icy surface, and then it repeats. And there's some cosmic rays in there too, just to confuse everything. But
Really, that is very good.
yeah.
Winter weather.
Yeah. Okay. And then there's the first sort of Kuiper belt object we've messed with in any kind of detail. And this is Ultima Thule, that the New Horizons mission, after going to Pluto, went and targeted this thing. And it's weird. It looks like an icy-ish body, reddish on the surface. A lot of these things are reddish because apparently you get these compounds called tholins that form when these organic compounds are exposed to ultraviolet light from the sun. And it seems to be two sort of pancake-shaped bodies. There's not much depth to this here, and that have touched gently and adhered together. And so that's telling us something about the formation of planets and stuff, that it wasn't always violent smack into and then re-aggregate type stuff, that sometimes it was just this gentle sticking together. And you kind of see that in the chondrules that are in the
So this
Stony
one here
Meteorites.
is flat.
Yes, this is a place that really is a flat world. and the flat earthers are actually taking a cruise, and so somebody said, okay, you gotta go down to Antarctica and sail all the way around Antarctica to, you know, because they're saying Antarctica is really just this rim of ice that goes all the way around a flat Earth. And they said, no, we're not gonna do that. Of course they're not gonna do that. So they don't see too many craters from impacts on this. They do see signs that this thing kind of smacked in here and slid over, you know, stuff like that. But if you go to the New Horizons website, you can just get all the latest. They're still streaming data back from that encounter that happened over the New Year. So it's going to take them a couple of years to get all the data back, because the data rate's so slow coming from that far away. I mean, this is 6 hours by light travel time away.
There's a rotating animation of it.
There is, I don't have it.
Yeah.
But it's rotating this way like a propeller, and it's pretty cool. Yeah, go to New Horizons. And then there's stuff from outside of our solar system. So this is good old Oumuamua that somebody mentioned earlier. So this thing came in, and from its trajectory and its velocity, we can tell that this thing came from outside of the solar system, and in 2017, and it is heading out of the solar system again. And so we just got that one look at it, and we actually discovered it after it was, I think it had already gone past the sun, it was on its way out. And it's out there. It's not out of our solar system yet, but it's heading there. And from, you know, the spectra and the brightness changes, they see this tumbling thing, and they try to model the shape of it. And so one of the shapes they get is kind of this elongated thing, something like 400 feet long, tumbling reddish with the tholins on it. They're not sure. They think it's mostly metallic, so it seems to be pretty dense. And of course, everybody's saying it's an alien spacecraft. And one of the models I know Jared was showing looks like the Millennium Falcon coming in. So that's way out stuff that hasn't, as far as we know, hasn't landed on the Earth yet. But if that stuff's coming in, there probably is some of it sitting out there. So that's all you have to sit through.
Question.
Yes. I have a question. So, when you see a little rice-sized meteor in the sky, how far is that from you?
70 miles up, usually.
70 miles, okay.
You know what? I used to have a whole thing, and somebody asked about the Chelyabinsk impactor, and I used to have a whole segment in here on that, and I took it out. So I apologize, I have to mention that. Somebody asked how big that was. That Chelyabinsk impact, or thing that blew up in the upper atmosphere, was 60 feet across, and it was stony. And the biggest piece that they found that remained was 3 feet across. So that thing detonated with like 500 megatons worth of energy, or kilotons of energy in the upper atmosphere, and mostly turned into dust. But the shock wave took 90 seconds to reach the ground, and people had time to go stand in front of windows looking at it. So they had 1,500 people injured by flying glass.
Some conjecture here. If we find some living little organisms on Mars, and we have been there someday, those astronauts would probably not be able to return to Earth right away. They'd be quarantined like hell, wouldn't they?
Probably, and you'd have to figure out too, is that stuff that we introduced to Mars? Because I don't think we were too careful about sterilizing some
That's what I
stuff.
said.
Yeah,
Yeah.
definitely not to the moon.
I was fortunate enough to attend an astronomy gathering in Big Bear about a couple of years ago, and I won a little prize. This is a piece of lunar meteorite. If you'd like to see it, please come up and see me. I will not pass it out.
So that's a bigger chunk of the moon. All right, Mark.
We're not supposed to have anything on the moon, so.
No. You're allowed to own meteorites from the moon. It's Apollo lunar material you're not supposed to have. So.
Question.
Yeah, when a meteor comes into the Earth's atmosphere, it heats up from colliding with the air, surface gets very hot, it ablates, the gas flows off, particles blow off. But occasionally these meteorites, like the Monticelli events, explode.
Especially the Stonys.
Why does it explode?
Because there are little cracks in the structure. It's not really tough like the nickel irons, although they can do it too. And as soon as you get some air, you stick your hand out of your car going at 70 miles an hour, you got this huge amount of pressure. As soon as they start breaking apart, that's larger surface area. And so now there's more and more surface area, and basically all that kinetic energy starts turning into thermal energy right there, and they just burn up.
Another way to look at that is if you take a Pyrex dish and you put it in your freezer, and then you take it out and you put it on the stove and turn the flame on underneath of it, you risk an explosion because of the thermal variation. And this thing came in from deep space, so it's saturated with cold.
So
All of a sudden,
the
the outside's getting hot.
explosion, it should just continue to ablate, just ablates
Now,
fast.
somehow
Why does
March
it
explode
explode?
wrong.
It's because just all of a sudden you force open those cracks and you got much more surface area, so now there's much more resistance, so there's even more force on it. And just the end result is to suddenly transform all that energy into bad news for the structure.
How would they divert some of these meteors coming into direct? I mean, this would be a massive problem.
So it could be, depends how far away you find it. So if you're trying to divert something that you see as on a potential collision course with the Earth, the farther out you find it, the better off you are, because the less you have to nudge the little thing to make it miss. And so one method is just splash a bunch of sunscreen or white paint on it, something very reflective, and that would change the reflectance, and reflecting photons transfer momentum, and so now suddenly you've changed the trajectory of the Earth.
Yeah, they're actually able to measure the change in the rotation rate of Bennu right now. That's an interesting.
From the
study.
Yarkovsky effect, yeah.
From the sunlight, right, exactly what you said, yeah.
Yeah. So that can spin things up or spin things down, and you can use it to change the trajectory. You could go up with something maybe the size of a semi, which we can't launch now, but you could go up there with something big and just park it next to the asteroid and have little, like a radar system and small jets on it, small rockets, so that as the thing gravitationally moves towards you, you just keep inching away, and you can tractor it away that way. You can try, hitting it with a laser. If it's something pretty solid, you can hit it with a laser and stuff will ablate off and act like a rocket and push it away. So there's multiple things people are looking at besides just, sending Bruce Willis up there to push on it. Yeah, I mean,
But Bill Lubin comes, you should get him to tell you about that.
Yeah.
That's one of his ideas, actually.
Yeah. But,
the laser ablation.
I mean, spend a couple of billion, save the Earth, or not, well, we're already doing that decision. We're saying, oh, well, let's just keep burning oil. So, obviously, we'll say, just let the asteroid hit. It might have oil.
What happened in Siberia in 1908, that hit downtown Hong Kong, or
Yeah, oh yeah.
a real big total disaster.
Yeah, even the Chelyabinsk one, if it had happened in 1983, would have probably started a nuclear war, because the Russians would have assumed that was us setting off a nuke in their atmosphere. Because that's one of their big industrial areas, so. Okay.
Thank you, Professor McPartlin. I want to thank Sean Kelly, our connection to the City College, for getting all his students to come on the second Saturday Star Party. Because I don't know how many people we'd have here without him, but I certainly don't see around. Really?
Hopefully we'll get good weather next week, Frank.
That's next Saturday, and there's a meeting, as the president said before, at 5 o'clock right next door. And this coming Monday, 3 days from now, we're gonna gather around the radio microphone and talk about a lot of the stuff that happened here. And Dr. Woodmeister, get well, wherever he is. We'll have Phil Newman here next week. You wanna start the food line like most of you do, or?
Oh, I'm fine,
Okay, let's see. You get back on your meteorites?
Oh, I don't know, I'll see.
My camera doesn't work. And something, I'm not sure if it happened before. It's kind of going on and off. Might be the lens I have on